I'm pleased to welcome you here at the Technical Forum at the group exhibit Hydrogen Fuel Cells, and for the first time this year with batteries. Please come in, have a seat, have a drink on the house and enjoy with me our next presentation dealing with the topic power to gas under safety aspects. And we will continue then our program at this point with another overview about storage in the underground. And this second presentation will be held by Andreas Acht from Deep Underground Engineering. But now, at first, we will have the presentation Power to Gas under Safety Aspects, and your presentation will be the PR and Dissemination Head of HySafe, Dr. Ulrich Schmidtchen. Give him a big hand, please.
Oh, those were really many hands. Thank you very much. Yes, well, thank you for coming here. I am here as a representative of HySafe. And HySafe is the global association for the safe handling of hydrogen, in particular, as long as you use hydrogen as an energy vector. So we are not so much a part of the chemical industry. The people there, they know very well how to handle hydrogen safely. But when it comes to hydrogen as an energy vector, this is a field where many people come in who have no technical knowledge. They simply know how to drive a car, but they know little about hydrogen. And I think here is a lot of dissemination, education, and training necessary in order to make hydrogen as normal and as safe as natural gas. And that is the objective of HySafe. So the vision is we can be pretty certain that hydrogen will in the foreseeable future be introduced as a sustainable energy carrier, and it must obviously be safe. Otherwise, nobody will buy the stuff. And the mission of the association HySafe in this context is to facilitate the international coordination, development and dissemination of hydrogen safety knowledge. Because there is a lot of hydrogen safety knowledge, but not all the people know of each other. And we want to be something like the hub where the knowledge about hydrogen safety is collected and where it can be dispensed just as necessary, just as people need it. Hydrogen safety research, education and training, all these things must fit together. Quite formally, HySafe is an association, a non-profit association under Belgian law. It was founded in 2009 in Brussels, where we have also our legal seat. And at this time, I should have corrected this. We are about 30 members. And about these members, there are public institutions, there are national labs, there are universities, and there are also private companies. At this time, we are a bit more research-oriented, but we expect that also the commercial companies will come in as soon as they step into this market. And membership is mainly European. Another important part is from North America. We have, at this time, one member from Asia, but we hope that there will be more. Maybe we can make some advertisement and we can make a few members. In June, there will be the World Hydrogen Energy Conference in South Korea. There will certainly be many people from Asia present. One of the most important activities of HySafe is to make the International Conference on Hydrogen Safety, the ICHS, which is held every other year in various places. The first time was 2005 in Pisa. The last time was 2013 in Brussels. And the next one will be held next year in Tokyo in October. So here you see the participants of the 2011 conference, which was held in San Francisco. In the background, you see the prison island Alcatraz, but this has nothing to do with the conference. We do this conference, which has a pretty large scale, a few hundred people attend, but we do also education and knowledge dissemination in smaller scale. We have workshop, seminaries, training courses, and so on, depending on what people want. Sometimes we do this in conjunction with important conferences. For example, this year, Toronto 2012 was in conjunction with the last World Hydrogen Energy Conference, which was held in Toronto, and San Francisco 2011, which was this was held in conjunction with the Hydrogen Safety Conference, which was at that year in that place. But this is not necessarily so. Berlin 2012, this was not in conjunction with a major conference or another event. It was made simply in conjunction with our annual meeting of members. We also have a working group which tries to coordinate research priorities. They meet occasionally and they try to set up an overview. Where are the points about which we know already a lot, and which are the points where more work is necessary, and who is able to do this work. And then, of course, it is tried to bring this into shape so that people can do something about it, and it can be done at the place where it is best. We also publish literature about hydrogen safety. You probably know the International Journal of Hydrogen Energy. At the state where we are now, we have an agreement with the publishing house that HySafe is caring for the contents of a few issues in certain intervals of this journal. These issues are then filled with papers about hydrogen safety. Of course, our long-time objective is to have a journal of our own on hydrogen safety, but we are not yet there. But I think we are making progress. The whole thing is not so much about fundamental research. The whole thing is about application. It is about addressing industry needs. You all know that hydrogen is leaving the research and the demonstration phase. Of course, in 100 years we will still have hydrogen research, but the hydrogen is now leaving this phase and is going into the commercialization phase. In different fields of hydrogen applications we are close to the market entry, or the market entry has already happened. And this raises questions which are hydrogen safety related. For example, the behavior of composite cylinders, in particular in unusual circumstances. What about fast filling of a car at the hydrogen filling stations? There are huge pressure gradients and also huge temperature gradients. And to which extent can you do this? The interaction of H2 and metals, the release of hydrogen outdoors and indoors, and other things. For example, what about safety distances and so on and so on. All these are things. On these questions there are either very little answers or there are different answers in different parts of the world. And we want to try the customers to help this. We also work together with people who collect databases and compilations of lessons learned. For example, Hyatt is in Europe, EIGA is also in Europe, H2 Incidents is from the USA, and with all these people we cooperate. The role of standards in hydrogen safety is sometimes overestimated, because hydrogen safety does not come from the standards. But of course you need standards in order to use hydrogen reliably and reasonably. And so it's not surprising that HySafe is also a partner in standardization. In particular in ISO, in the International Standards Organization, in the TC 197, which is specially dedicated to hydrogen technologies. HySafe is an official partner of this committee, but we also work together with other committees of ISO, for example 220 for cryogenic vessels, on TC 58 on gas cylinders and so on. All these people, they need safety-related knowledge for their work, and they get it from us. So, just in case you want to know more about HySafe, you can look up our website, or you can contact me. This is me. My main job is that I am a member of BAM, the Federal Institute for Materials Research and Testing in Berlin. BAM is a member of HySafe, and being a board member of HySafe is something like a side job from me. Yes. hydrogen will certainly be a part of our energy system pretty soon. It must be a safe part of our energy system. And it will be necessary to handle hydrogen in pretty large amounts. Because you all know that here in Germany, for example, we have a lot of wind energy. And sometimes these wind farms, they generate more electrical power than you can feed into the grid. This is so already now. And in a few years, when all the offshore wind parks in the Baltic and in the North Sea, when they come, then the problem will be even bigger. Okay, what can you do with the excess power? Simply throw it away? Okay, yes, technically you can do it, but economically this is not a solution. Power to gas is one solution which is proposed, and this will certainly help. With a good electrolyzer, and here on this show you find many electrolyzers, you can convert the excess electrical power into hydrogen, and you can store this hydrogen. But how exactly do you do this? These are very large amounts of hydrogen. You cannot simply keep them in a few cylinders. Well, one way to store really large amounts of hydrogen is to store it in underground caverns. This is a system which is already applied, for example, to natural gas and to other things as well. However, I must confess that I am not an expert on underground storage of hydrogen. So in this case, you must ask the people who know about it. I would like to invite Mr. Acht to the podium. Well.
Hello, everybody.
And, well, he certainly knows.
Yeah.
And I think you will give us now a short introduction into the topic.
Yes,
And
I will do. Thank you for the introduction,
here we go.
Mr. Schmidtchen. Yeah. Yeah, when it comes to hydrogen storage in large-scale amounts, we have to talk about underground storage. Here on this picture, you can see all kinds of underground storage, like aquifer formations, depleted gas fields, or even here, salt caverns. So I'm from the company of KBB, and we are an engineering company who can provide engineering for every kind of storage facilities like these. Yeah, here you can see a hydrogen cavern in the salt, a compressed air cavern, a crude oil cavern, and a natural gas cavern in a salt dome in this picture. So I've prepared some slides. These slides are in German language. Sorry about this. If you don't understand anything, you can just ask questions, or you can ask for the slides as well in English. So, yeah, we already have a big natural gas grid here in Germany. The capacity is about 200 terawatt hours. That's approximately 25% of the yearly consumption, and approximately half of it is stored in salt caverns. So this could be a gas grid, a power to gas grid in future. So we use our excess energy, run electrolyzers and store the energy in those salt caverns, and we can supply the mobility sector, the industry, the natural gas grid, and we can also re-electrificate it in gas turbines or fuel cells. What we also can do is create methane out of it by combining it with carbon dioxide, and then we have synthetic methane, which we can use in the same way like natural gas today. When we come to storing of hydrogen in those caverns, we don't have a cavern where we store hydrogen in Germany today, but there are some in the world. We have 3 in England, and also 3 in the US in Texas. So these are in operation since partly since the 1980s, and they are still under operation, and they don't have any accidents with this. So when it comes to safety, it seems to be quite safe, but in Germany we have to do some adaptation work because we don't have experience with underground storage of hydrogen, and we have to do some adaptation from storing natural gas coming to store hydrogen in those caverns. So this is a sketch of a cavern. Here you can see the amounts we can store in such a big cavern. It's about 500 cubic meters size, 500,000 cubic meter size, sorry, and we can store approximately 4,000 tons of hydrogen in it. So that's a big amount of energy. It's approximately 133 gigawatt hours we can store. Yeah, when it comes to safety, we're right now working on these issues, on the issue tightness and the issue material. You can see here the main thing we're working on is the well to the cavern. This is a sketch of a well, and you can see here the production tubing to the cavern, and you can see here the salt and the overburden. This is the well head of such a cavern. Yeah, what we're working on right now are seals. Are they tight for hydrogen, not only for natural gas, and is our salt tight for hydrogen? It seems to be like that because hydrogen is already stored in caverns in the US and in England. So, but we have to prove for our German government that our salt is also tight for hydrogen. So what we're also working on right now is the topic materials. Maybe you know hydrogen can have some involving topics on steel. So we're talking about what's the English word of hydrogen? Wasserstoffversprödung. I don't know now. Hydrogen embrittlement, exactly. Sorry. That's what we're working on right now. If we can use our steels we are already using for natural gas caverns, if we can use them also for hydrogen, if there is any safety issue, we would change the steel into another one. So that's what we are doing right now. We do some testing at the moment. It's not that important. Here you can see a salt map of Germany. It's about the potential of this technology. We have some net integration points of offshore wind farms. Here you can see the red dots, and the blue colors are the salt formations beneath the earth, in the earth, and next to every integration point you can see here we have a salt formation we could use for storing excess energy out of offshore wind farms in those salt caverns we could construct in those salt formations. You also can see a salt map of the whole world. You can see salt formations in the US and Canada. Also everywhere in Europe, in Africa we have several salt formation, and in South America. So this technology has a quite huge potential, and we could use those salt caverns for storing hydrogen all over the world, almost. Not in every region, but on every continent, let's say. So here, this is a storage system in one of our studies we wrote until now. You can see here an electrolyzer, here electrolyzer, a compressor, the cavern storage, a trailer filling station, and a power plant for re-electrification. And we were calculating some prices of this grid scale storage facility, and the prices you can see here, the costs. The whole system would cost 920 million euro for 500 megawatt storage power plant, and the cavern storage costs would be 10% of this, so approximately 90 million euros. So it's a quite expensive storage technology at this time, but this costs will decrease. Of course, the costs of the electrolyzer will decrease in future. So the whole system will be cheaper, and maybe we're gonna have an economical way of operation this storage system in future, because without any nuclear backup power plants and without any fossil backup power plants, we're gonna need such a storage system in future. So this was my part.
Thank you very much, Mr. Acht.
If you have any questions, just ask me.
Yes, I have a few. So would you allow a few very silly questions from a simple mind?
Of course.
So you are telling us that this is not some distant vision, it's not a technological dream, it's a proven technology. Is this true?
This is true. So, it works again. Yeah, it's a technology we are already using since the 1960s here in Germany. Salt caverns for crude oil and natural gas, but not for hydrogen until now.
But I have learned that there are already a few examples that hydrogen as well can be stored in such caverns.
Yes, they do it in the US and in Great Britain, but not for storing green energy or something like this. It's just for security supply of the industry.
And what can you store in such a cavern? Everything, or probably not?
Yeah, this storage cavern is constructed by solution mining. So we use sweet water and wash the salt out of the salt dome and create a big volume. So we can store everything in this cavern which doesn't dissolve the salt. So like
gases are
gas,
no problem.
Hydrocarbons.
But you can store water.
Yeah, it will become to salt water. To brine.
This looks very nice. It looks almost too simple. And now the big question is it safe?
Yes, it is safe. We have no real accidents with such caverns. So the biggest accident that could happen would be a blowout of a cavern. So it's this whole thing is under pressure when we store gas in it, up to maybe 200 bars. And if somebody would rip off the wellhead of such a cavern, we have maybe I can show this picture again. We have an subsurface safety valve. So if somebody rips off the wellhead, this subsurface safety valve would close, and if this one would fail, the biggest accident would come. It's called a blowout. So all the gas would stream out or flow out the cavern and would burn. So we would have a big fire, but no explosion or something like this, because there's no oxygen in such a cavern. So there's no explosive mixture, of course.
So in other words, this is not an underground powder barrel.
No.
Okay. Yes. So, well, this is good to know. But maybe some people remember that you had such an accident with one of these caverns in northwest Germany a few months ago, and a certain amount of oil came out and flowed into the River Ems. Could you tell us a bit more about this?
Yeah, it wasn't the River Ems. It was another river, far more east of the River Ems. But yeah, there was an oil accident. Approximately 40 cubic meters of oil flew out of a pipeline system, and it was just a pipeline system. And this pipeline system belongs to the company which runs these caverns, but it wasn't actually a cavern accident. It was a pipeline accident. Even it wasn't an accident. Just a valve wasn't closed. It was a small 1-inch valve which wasn't closed for approximately 18 hours. So it could happen everywhere, I would say. It doesn't. It's not connected to the technology of caverns.
So the cavern was not involved.
No.
It was some silly human who didn't do this.
Yeah.
Not so much a technical problem.
I think so. Yeah.
Well, this is of course good to know.
Nothing broke. It was just an open valve.
Yes. And well, we all know, even if hydrogen would come out of a pipeline or a cavern or from wherever, it wouldn't pollute the water, wouldn't it?
No, it wouldn't pollute the water. The worst thing which could happen is a blowout, so a big fire.
I thank you very much for these informations, and if anybody of you has any questions, well, grill us.
Yeah, thank you both guys, for this very informative overview. So, but I'm sorry, we are at the end of the time for your presentations and the interview. So if you have, yes, if you have any questions in your mind, I think you will be in the back of the technical forum, and you will come. You have the possibility to come to this both experts and ask your questions right then. Okay, thank you very much. It's your applause here right now. So we have a short break, and we will continue with a similar topic, reforming of natural fuels to hydrogen on demand, no storage required. Okay, thank you very much.